Today we are going to look at the structural steel, a critical substrate for commercial building. In 3D view, go to the lower left corner of the screen. Beside the scale, click on the second button, which says Visual Style. Click on Wireframe. Now we'll be able to see how the building supports itself. Our exterior wall is not load-bearing. This structure is a classical example of standing alone steel-framed building. How it works is the steel columns will go first. Beams and girders are supported by the column. After that, the steel joist will be supported by the girders. Go to section 1. We should be able to identify the columns, the beams, and the joist. We also notice on every floor, including the ground floor, they have 1.5 inch metal deck. That goes from the ground floors first, second, and third and fourth. But don't forget, we have a roof structure. Pick the roof. Click on Edit Type, click on Edit Structure. The roof deck is a 1/4 inch, which is different from the one that's being used for the floor. Let's pick a column above level 2 on grid line C. This is a W10 by 49. The W means it's a wide flange shape. 10 means 10 inches. 49 means linear weight, 49 pounds per linear foot of the column length. You can also see more about the column by clicking Edit Type, 49 as the linear weight. Click on the preview. You can see what the column actually looks like. One thing that we need to notice is the column currently has a -5 inch offset for the base. This means the column does not stop at the floor level. Actually, it goes lower for 2 inches. Some of us probably will say that the column was trying to reach the beam underneath. If you click the beam, and the beam actually also have 5 inch offset as well. However, if you look at the columns, beams together from floor to floor, you will notice this is actually a design conflict. The column on level 1, the top, doesn't have any offset at all. REVIT actually has a tool for this. It's called clash detection. With the column selected, go to Collaborate tab, click on Interference Check, run Interference Check. On the left side, this is the column you selected. On the right side, you can switch to Current Project. You can pretty much check everything that you have to see if the column has any conflict with everything else in the project. But most likely, like we said, will be some structural elements. Now we're getting a report about all the interference. For example, the one we looked at was 2 columns from first floor and also on the second floor. They do have some conflict because of the offset. This concludes the exercise for today. Hopefully you enjoyed everything so far about BIM.